Hello everyone, I am Babruvan Solunke, Assistant Professor, Department of Computer Science and Engineering, Walchand Institute of Technology, Solapur. In this session, I am going to teach random forest classifier of the second unit of machine learning, supervised learning classification. Learning objective. By the end of this session, you will be able to understand the working of the random forest classifier, identify the various applications and Python implementation of the random forest classifier. This random forest algorithm is a type of supervised machine learning algorithm that builds the decision trees on different subset of the samples of the given data set and take the majority voting mechanism for classification and averaging mechanism in case of the regression. The concept of the random forest algorithm is based on the ensemble learning. Ensemble learning is a general meta approach in machine learning that seeks better predictive performance by combining the prediction from the multiple models such as decision trees. Its name is ensemble because here we are combining the multiple decision trees and combining the multiple predictions of this decision tree for the better predictive performance of the model. We use this algorithm as a classifier that trains multiple decision trees in parallel on random subsets and features of the given data sets. The random subsets and features are called as bags. So this algorithm is also called as a bagging type algorithm. It collects the prediction from each of the decision tree for a new input data point once the training is completed. This model do not rely on a single decision tree, but it takes the prediction from multiple decision trees and then based on the majority votes of the prediction for the class labels in the input, it forecasts the final output. Therefore, the overall prediction accuracy of this model will be improved. Following are the algorithmic steps of the random forest classifier. In the first step, the random data selection has been done. The algorithm select k random subset of the data points from the given data set. Then on this random subset of the data set, it builds the decision tree. It creates a decision tree for each of these k selected subsets, give the training to these decision trees by using these different subsets in parallel. We can repeat this step number 1 and 2 unless and until we have the sufficient number of the decision trees have been successfully trained on the different k subsets. Then in the next step, when a new data points comes for prediction, it get the prediction result from each of the created decision tree in the step number 1 and 2. Then perform the voting for every predicted result, that is class labels. Once the predicted result have been performed and voting is collected for each of this class label, it can select the most voted prediction result, that is the class label, as a final prediction. Here this figure 1 illustrates the working of the random forest classifier. Here the original data set divided into the random subsets called as randomly selected data 1, data 2 up to data n. And on this randomly selected data sets, we create the decision tree 1, 2 up to n. Each of these decision tree will be trained in parallel on these different random subsets, and they give the final predictions to the decision to the random forest. Here the random forest collect the prediction result from each of this decision tree. After collecting this, it can apply the voting mechanism for the class labels. The class label which is having the highest majority will be the final prediction. The greater number of the tree in the forest will lead to the higher accuracy and prevent the problem of the overfitting which is faced in the decision tree. That will be resolved by creating the multiple decision tree in the forest and now doing the voting mechanism for getting the final prediction. Here we have the example of the working of the random forest classifier on the fruit images. The data set is given to the random forest classifier. The data set is divided into the multiple subsets and given to each of this decision tree 1, tree 2 up to tree n. After completion of the training, when a new input image is given to the decision trees, this decision tree will give their predictions. Tree 1 give the class A, tree 2 give the class B and so on in this way. Okay. And once the predictions are collected from these multiple decision trees, it can perform the majority voting mechanism. Here, most of the tree are predicted the final result as the given image is an apple image, and only few decision tree are saying that the given image is a banana image. Therefore, the majority is for the apple images. So, class label is apple. Therefore, the final prediction will be the apple image. Then the benefit of using the random forest algorithm, it takes the less training time as compared to the other algorithm. Why? Because we have divided the data set into the different subsets and created the multiple trees on these subsets in parallel. This decision tree will be run in parallel instead of sequential. Therefore, less training time will be required for giving the learning to the multiple decision trees. It predicts the output with high accuracy even for the large data set. It can also maintain the high accuracy even though we have the large proportion of the data is missing. It does not suffer from the overfitting problem. Why? Because it takes the averaging mechanism of for all the prediction or majority voting mechanism for all the prediction in case of the classification. Therefore, it cancel out the bias error present in the predictions. Therefore, the overall performance will be get improved, overfitting problem will be improved by selecting the appropriate number of the decision trees. This algorithm used in both task classification as well as regression. We can get the relative feature importance present in the data sets, which feature is more important from the given data set, which help in selecting the most contributing features for the classifier for making the accurate prediction. Take a pause and give the answer for the question. Which of the following statement about random forest classifier is true? We have the 4 options here. Here the correct option is C. It builds the multiple decision trees on random subset of the data and features and combine their predictions using majority voting mechanism. Now the application of the random forest classifier. We have various application in different domains, but some of the important domains we have selected here where we can apply the random forest. Banking sector. Mostly we can use this algorithm for identifying the loan risk, whether the loan should be given to the customer or not based on the history of the given customers. Then in the medicine field also we can find out the disease trends or risk of the disease. We can find out whether the disease is having to the patient or not by analyzing the different features of the symptoms of the patients and recommend the appropriate precaution also based on this disease trends and the risk. In the land market also we can use it for identifying the areas of the similar land use. In the marketing field, for finding the trends in the markets, whether the trends are increasing or decreasing. So such kind of the trends in the market can be analyzed by using the random forest classifiers. Now how to implement this algorithm in the Python by using the sklearn library, that is a scikit-learn library. In Python we have random forest classifier as a class which is available in the sklearn.ensemble package. So we need to import this given random forest classifier from this package using this given statement. In the next statement we can call the constructor function of this class random forest classifier by passing the appropriate number of parameters. Here the first parameters is called as a n_estimators. Its a default value is 10, but we can change the value appropriately depending on the size of the data and depending on the type of the problem. Here the n_estimators indicate the required number of the decision trees to be created in the random forest. Second is criterion equal to entropy. Here criterion is a function to analyze the accuracy of the split at each node of the decision tree. Here we have the taken entropy as a criteria for the information gain. The feature which is having the less entropy and the higher information gain will be selected at the appropriate node for splitting the given data set into the left and right branches of the decision trees for making the final decision. And after, we can give the training to the random forest model by using the fit function of the object of the random forest classifier. The fit function requires two parameters, that is xtrain comma ytrain, because the fit function is used for giving the training to the random forest classifier. Therefore, training data set is required, and this data set is in the form of the xtrain and ytrain, where xtrain act as the input feature matrix and ytrain act as the output feature vector. Then using the testing data set, we can ask the model for do the prediction, and the result of the prediction will be stored into the ypred variable. So this ypred variable is indicate the array of the predicted output. Actual output is available into the ytest, and predicted output is ypred. So by using this ypred and this ytest, we can analyze how accurate our model is. Suppose we have 10 actual output and model has predicted 10 predicted output. Among that, 7 output are correct and 3 output are wrong, which are not matching with the actual output. So in this case, we can estimate the model accuracy as 70%. So in the classification algorithm, we have the different performance metrics like accuracy, precision, recall, F1 score, ROC curve, etc. By using this different performance metrics, we can evaluate the performance of the random forest classifier. These are the references. Thank you.